Hello, everyone. Welcome to the Deminar. Today's series is going to be about bond analytics. So we've been working a lot with asset managers, hedge funds that are looking at piles of legal agreements specific to deals that they're looking at. Think CLOs, collateralized loan obligations. Think portfolios of bonds. Fixed income has been a big focus of ours. So I'm going to show you today is analyzing a bond in a more structured way. Some of our customers call it thinking it through insofar as structured logic, as opposed to just a bunch of free-form text. Because if you look at a bond, there's a whole bunch of legalese, there's a whole bunch of room for interpretation, and there's a whole bunch of natural language that outlines the risks associated with the company and the deal. So let me jump in here. With the platform, you create applications. Each application will have multiple guardrails or can have multiple guardrails. And you design the applications at the get-go. You spec it out based off of the use case at hand, the policies that want to be enforced, and all the associated rules that will be part of an advanced workflow like this. So this is called the DAG, a directed eclectic graph. It's a one-directional workflow. And this is either auto-generated, or with this interface here, you can pull things in, like add in chunking strategies, add in regexes, add additional guardrails in. Once this is set, and let me just get out of here, you then go to create the guardrails. If they were auto-generated, then they'll show up as red right here. So someone has to come in here and do something to accept it. Usually that means a review, which I'm going to show you in a second here. So I'm going to get into this particular one, payments and priorities. So this is leveraging any LLM. In this demo, we're using GPT-5, but any open source variety, we have a strong relationship with IBM. So any model that you can find within watsonx, any deployment can be done with Jaxon too, whether through a cloud environment or on-prem. It's an important aspect of a lot of work we do with the US Department of Defense, which is be able to operate without phoning home, without potentially sharing sensitive data. All right, so we have a mainline LLM, which is usually a faster LLM. In this case, we're using GPT-5 because now 5 has delineated or made it easier to pick and choose automatically between the fast models and the more slow, quote unquote, reasoning models. They call them reasoning models, but truth be told, they're not really reasoning. They're doing things like chain of thought and mixture of experts, which is better, and we recommend it for this utility LLM. I talk about it like that because what we're doing here actually is bringing the reasoning to the equation. Because what we're ultimately going to be doing is running programs through solvers that deterministically prove compliance with the rules that we're going to establish here. All right, let me keep going here. So this is an actual policy document that a bond analyst has written insofar as what they're looking for in any given deal. And that policy creation process is something that we're leaning on LLMs for. So basically, a human speaks their mind, and then we auto-translate that into a policy. Not translate, we auto-create a policy based off of the input text. Or you could have an existing policy that you ingest. All right, once we have the policy, we are turning it into a bulleted set of rules. So these rules right here are in natural language still, and humans can come through and confirm that this reflects the policy that was created. This is important because this is teeing it up to be converted into code, which is our secret sauce. Is we're taking natural language like these bulleted set of rules, and we're turning it into code, or what we call DSAIL. DSAIL stands for domain-specific AI language. And it's basically machine speak, so that AI applications can lean on this to get the verification that it is or isn't in compliance with these rules being established. I'll get more into that in a minute here. So if you look at it, there's a bunch of Booleans, there's a bunch of assertions, and each one of those lines of code are going to be checked against a question-answer pair on new data being processed. In this case, it's going to be a new bond being analyzed. Before we get there, though, we are using that utility LLM again. By the way, each one of these steps is calling on that utility LLM to perform, say, the conversion of the natural language into the code, and then again, the code back into natural language, and it's in the form of questions now. So each question can be confirmed by the SME. Each question has the ability to add additional context, which becomes really important when it comes to the interpretations that currently humans are doing on a given piece of text that's still following a policy, but is very much a qualitative decision that they need to make. This context is basically the institutional knowledge that's inside of the analysts and SME's heads that we can capture, codify, and keep, reuse, and never leaves the organization. All right, so this is an important field right here. So all of these questions, once they're set, will be confirmed, wrapped up into a master prompt. And then all of them go back to an LLM. Now this is the mainline LLM with something to process. In this case, we're processing a bond. It's going to find the representative answers to those questions. The LLM is that is. And those question answer pairs are what we're checking against these rules. So this is our playground. This is checking the whole bond against every one of those rules. And it comes back with whether or not it is in violation, it isn't, or it doesn't have enough information, or it's unknown to make that determination. In data science speak, it's a satisfiability problem. Did you satisfy? Was it not satisfied? Or is there not enough information to satisfy a given rule? So you'll see that there's a whole bunch that do get violated, some that are unknown, and you get this table down here that gives you a confidence level on the whole entire bond, which is basically saying, does it or doesn't it meet or comply with a given rule? And now this is an interface for the bond analysts in this case to dig into, what is this rule that was tripped, and how am I going to mitigate it or decide that this is a bond that we are not going to purchase? So ultimately, these flags, the rules that were tripped, are tools that the analyst can use to turn knobs and pull levers in an analyst agent level UI that I'm not showing here, but I will in a future Deminar. It's in the making right now. But those knobs and levers relate to these rules. So the rules are established here, but the analysts have the ability to basically have an advanced search feature to compare and contrast all the different risks. And in this case, for bonds, it's the covenants that really matter. That's where the teeth is. The covenants that outline the terms and conditions that the companies that are issuing the bonds must follow. So quick diatribe on that. Bonds are issued by a company. There is a trustee that they work with, the Goldman Sachs, Morgan Stanleys of the world, that will then sell it into the markets. That bond indenture, that is a legal agreement between the bond issuer and the trustee, is what I'm talking about when it comes to these covenants. But everyone that's in the process looks at these covenants to determine how much protection it gives against the risk. So is the yield plus the risks that are known and the mitigations that are included with these covenants something that fits our strategy as, say, a hedge fund? or a specific portfolio within a hedge fund. The policy of that analyst is directly reflected in the guardrails that we're creating here. All right, well, I would love to speak with you directly if you're interested in learning more about how this can be used for fixed income or any use case, really. This is a generic platform. I didn't really show all the different capabilities beyond bond analytics, but any natural language use case that has policies that could be enforced or rules that are associated with the processing of data, Jaxon can be applied to. So please reach out. You can reach me at jaxon@jaxon.ai or come to our website, jaxon.ai. Thanks all.